In the following video we're going to consider two problems. To find the angle formed between a line and a plane, and then secondly to find the angle formed between two planes. So here's the first one. What I would like to do here is find the angle between a line and a plane. So here we've got the Cartesian form of a plane and underneath the Cartesian form of a line. And what I'd like to be able to do is to find the angle between those. So it's really helpful to be able to visualize this problem. You can probably see on the diagram there the angle that I'm after. Now then, what about the information you're given then? In terms of the line, you can convert this Cartesian form into vector form and find the direction of that line. But what about the plane? The plane, well, the direction that we get from that is the normal, isn't it? So let's just have a look at this in the diagram. So I've just plotted on a normal there to help us see. The green line is going to be the direction that we have of the plane. So in this case here is 3 minus 1, 1. So the angle that I'm after here is the angle between the purple line there and then the yellow line, which is represented in the direction of the plane, so that angle there. However, what I'm going to be able to calculate is the angle between this line and its normal here. Well, hopefully you can see the relationship between those two angles there, and that they're in a right angle triangle. So if we can find this one, we could subtract it from 90 degrees and work out the one that I want. So the angle I'm going to be able to calculate from the direction of the normal and the direction of the line is going to be this one, and the angle that I want is going to be this one. And as we can see quite simply there, those two add up to 90 degrees. So once I've got this one, I can work out alpha. Right, let's give that a try. So the normal has a direction of 3 minus 1 and 1. And the direction of the line, well, because we've got it in Cartesian form there, it's not so easy to read off the direction. And it might be useful to put it in parametric or even vector form to be able to do that. So I'll just quickly remind you how we do that. If we set that equal to our parameter, then we can rewrite each of those. So x is equal to negative lambda, y is equal to 2 lambda 5 plus 2 lambda, if we put it in the order we want. Z is equal to lambda 8 plus lambda all over 2. So if we want it in the vector form, then we've got a point on the line, so 0, 5 and then 4, and then we've got a multiple of the direction, in this case minus 1, 2 and 0.5. So the direction of the straight line is minus 1, 2, 0.5. The direction of the normal is 3 minus 1, 1. So we can use that to work out the value of the angle. Let's just check my diagram again. Yeah, theta, and then use that for alpha. Okay, so how do we find the angle between two vectors? Yep, it's the dot product, isn't it? Okay, pause the video, try to do it yourself, and then I'll come back at you with the answer. Okay, so here we are back again. I'm getting an angle there of 126.3 degrees for the angle between the normal and the straight line. That's an interesting answer because that's giving me the obtuse angle here. Now, obviously, when we're finding the angle between two lines, there's two possibilities. On the diagram here, we've got the acute angle, and there's the obtuse one there that I've just found, theta. Put that one in red. And well, it really depends which one you're after, and I guess really that it should be made clear for us from the question which one that they're asked for. Okay, well, I'm going to go for the diagram here of what looks like I'm being requested for the acute angle here and therefore the acute angle there, and I'm going to go with that. So the angle that I've got there, I'll work out and I'll give you theta. So there we go, we've got an acute angle for theta to be 56.7, which gives the acute angle between the straight line and the plane to be 36.3 degrees. In this second example, we want to have a look at finding the angle between two planes. So here we've got two planes in Cartesian form, and here's what they look like. There's two possible angles that we could find there, but what we're looking for is the angle between the two planes. And again, I remind you that when we've got the planes in Cartesian form, then the piece of information that's important to us about the directions of the plane is given to us by the normal vectors. So if we've got this Cartesian equation here, then the normal to that vector has got direction 1, 3, 1, and the normal to this vector is going to be 2, minus 1, minus 1. So that's going to be the clue for us how to find the angle between the two planes. Since if this is the angle here that I want, then what we're going to do is we're going to find, or we're going to consider two normals to that plane, because we've got the angles for those, and since those two normals are clearly at right angles to the planes, then the angle that we've got here is going to be 180 degrees minus that one, and the angle theta is actually going to be this one here, isn't it? Now again, whenever we're asked for an angle between two planes, we don't know if it's this one here or the one on the other side there. So is it an acute one or is it the obtuse angle we're asked for? So unless it's made clear in the question, then we could find either. So in fact, if we just find the angle between the two planes, then it's going to give us this angle here, which is that one, which might be the one we're asked for. Okay, so as I said, it should be made pretty clear in the question which one you're after. So what I'd like you to do now is use those normals to find the angle between the planes. Pause the video and try and do it yourselves. So there we go, dot product of -2. The lengths of the two vectors there, root 11, root 6, so we get that for our cosine of our angle, and to one decimal place I've got 104.3 as the obtuse angle between the two planes. So that's how we find the angle between a line and a plane, and an angle between two planes. The key thing with these sort of questions is being able to visualize the problem in the first place. Now I've done that with a 3D bit of software, but you can easily do it with a piece of paper and a pencil for a plane and a line. Just get a visualization in your head of what that looks like, and then two pieces of paper, perhaps two pencils as well, shoved through to give you an idea of that. If you've got that clear, the reasoning's there for you, then the actual calculations are very, very straightforward. So take your time, get this understanding correct in the first place, and you shouldn't have any problems at all.